Hey guys, Mr. Backerberg here. In this video, we're going to take a look at limits that fail to exist. So there's a few things that can make a limit not exist. So if we're looking at the limit of a function, it doesn't exist if any of the following things happen. So if we look at approaching a specific constant, if our function approaches different numbers from the left side versus the right side, then that limit does not exist. Another thing that could happen is if your function increases or decreases without bound. So if it goes up to infinity or down to negative infinity as you're approaching your specific constant, that limit also does not exist. And then the last thing, if your function oscillates or bounces between two values as you get closer and closer to whatever that constant number is that you're approaching, then that limit also does not exist. And we'll look at examples of each one of these as we go through the rest of the video. So on this one, we're going to show that the limit does not exist. We're going to look at the limit as x approaches 0 of the absolute value of x divided by x. Now we can't actually plug 0 in because that would put 0 on the bottom of the fraction, and we're not allowed to divide by 0. So we're going to approach 0 from each side and look at what happens as we plug in values that get closer and closer to 0. So on the left-hand side, I'm going to start with negative 0.1. I want to start with a number that's close to 0, but I'm going to gradually work closer and closer to 0. I'm going to use my calculator here. So I'm going to store key that negative 0.1 as my x value. And then when I plug that in, I get negative 1 as my answer. But then I want to move gradually closer to 0, so I'm going to do negative 0.01 and store that as my x value. And when I plug that in, again, I get negative 1. And then I want to move even closer to 0, so negative 0.001. So if I store that as my x value and then plug it in, I get negative 1 again. Now we're going to work in from the right-hand side as well. So I'm going to start with 0.1, and we'll plug that in. And when I do that, I get positive 1 as my answer. And I'm going to move closer to 0, so 0.01. And store that as my x value, and I get 1 again, and then I'm going to do 0.001, and when I plug that in, I get 1. So as I approach 0 from each side, I notice that as I approach from the left-hand side, I'm at negative 1, but as I approach from the right-hand side, I'm at positive 1. So this limit does not exist because we're approaching different numbers as we come in from the left side and the right side. On the left side, we had negative 1. On the right side, we had positive 1. Taking a look at our next example, again, we're going to show that this limit does not exist. We're trying to approach 0, but we can't plug in 0 because that would give me 0 on the bottom of the fraction, and we can't divide by 0. So I want to approach 0 from each side. I'm going to start on the left side with negative 0.1 because I want to choose a number that's close to 0, but then gradually get even closer from there. So I'm going to take negative 0.1 and I'm going to store it in my calculator, and then I'm going to plug that into the function, and I get 100 as my answer. But like I said, I want to move even closer to 0, so I'm going to go negative 0.01, and I'll plug that into my calculator as well. And when I do that, I get 10,000. And then I want to move even closer to 0, so negative 0.001. And I'll store that in my calculator as well. And when I plug that in, I get 1 million. Now what I notice happening here is as we're plugging in these values, my answers keep getting larger and larger. And that would keep happening as I keep plugging in infinitely smaller values. The answers will keep getting infinitely larger. Let's see if that same thing happens on the right-hand side. So I'm going to go with positive 0.1, and I'll store that in my calculator, and then plug it in. I get 100, but then I'm going to do 0.01, so I'll store that in my calculator, and then plug it into my function. I get 10,000, and then I'll do 0.001, store that in my calculator, and then plug it in, and it looks like I get 1 million again. So as these values that we're plugging in keep getting smaller and smaller, our answers keep getting larger and larger and larger. So this is an example where our function is growing without bound, and it would keep growing up towards infinity as we keep plugging in infinitely smaller numbers. So this limit does not exist because this function is growing without bound. Now we're going to look at one more example here and show that this limit does not exist. So we're going to look at the limit of the sine of 1 over x as x is getting closer and closer to 0. And this one I think I want to look at graphically. So in my calculator, in the y equals, I have that function typed in. I do have to be in radian mode in order to graph this out. When I hit graph, I get kind of a sine wave. But what I notice is that as we approach 0 from the left side and from the right side, that sine wave is bouncing up and down between +1 and -1. So this is oscillating between those two values, between +1 and -1, as we approach 0 from each side. So because of that behavior, this limit also does not exist. That's going to be it for this video. Thanks for watching.